title 6.0. I'm actually making this years after I made the other videos in this chapter. So if something sounds different, if I sound older, more mature or something, that's the reason. I probably would sound older, more ancient by this point. Anyway, let's get into this. What we're going to look at is how to rewrite equations. This is going to be very, very useful for the rest of this chapter. So how you usually think about solving equations, rewriting equations up until now, especially if you've been in my class, is I stressed with you in grade 8 and grade 9, if I taught you, I stressed over and over and over what we do to one side of the equation, we also do to the other side of the equation. So for example, if I was solving this little equation right down here, 3x plus 4 equals 8, if I was going to solve that, I want to get the x all by itself, right? I want to isolate the variable. There's something else I slammed into your head thousands of times. So I want to get rid of this plus 4. So how do I get rid of a plus 4? I say minus 4. And what I do to one side, I also do to the other, right? That's that rule right there. What we do to one side of the equation, we do to the other. That's what keeps it balanced. We have to keep the equation balanced. So what's left over here now is 3x. This cancels out. Plus 4 and minus 4, gone. So that's gone. Then we have 8 minus 4 on this side is 4. And then the last step is we got to get the x by itself. Right now it's 3 times x. So we do the opposite. We divide, and what we do to one side, we do to the other side. So we're left with x over here. And you have 4 divided by 3. Yeah, you could divide 4 divided by 3 and get some crazy decimal, 1.333. But what we would tend to do is just put 4 over 3. 4 divided by 3, 4 over 3. Right? So that's what we've done in previous years. Now, there's another way you can think about solving equations. And I think it's going to be a lot more useful in this chapter if you think of it this way. What you can think of is moving terms to the other side of the equal sign makes their sign change. So you can just move something to the other side of the equal sign as long as you change its sign. Instead of adding or subtracting to both sides, just move something to the other side. So for example, we have this plus 4 here. In the same question we just did, but I'm going to do it again. I could take this plus 4 and I could move it over to the other side. But when it moves over, it won't be plus 4 anymore, it will be minus 4. Now that might strike you as weird, but look what we did right here. We minus 4 on that side. So, you know, some of you probably already think of it this way, but what I'm saying is it's probably going to be more useful for everyone to think of it this way from now on, and you'll see why in a second. Alright, if I was doing this question, what I would now have is still 3x here. The plus 4 is gone because it moved to the other side, and on this side we have 8 minus 4, which is 4. And then you do the same thing you did here. You divide by 3. Now I've always put divide like this, but another way you could write it is divide by 3, divide by 3. So the 3's cancel, you have x equals, and look, it's staring you in the face right there, you have 4 over 3. So a few subtle changes there, but it's going to prove to be useful, I think. Oh, one last thing. Some teachers, especially in elementary school, they teach this that if you're going to move the plus 4 to the other side, this is like a bridge here. There's equal signs like a bridge, and there's a mean little troll that lives under the bridge. He won't let you go over the bridge unless you give him something as payment. And what you have to give him is your sign. So this plus 4 gives up its sign and becomes a minus 4. Or a minus 4 moving over would give up its sign and become a plus 4. Right? You got to give up your sign. Cheesy, but maybe that'll help. Alright, so here we go. We want to get the y all by itself, and we want to make sure that the y is positive. So here's our y. It's already positive. We want to keep it all by itself. So what do we got to move? We got to move this, 2x, get that out of there, and move this minus 5. If we can get those to the other side, we'll be in good shape. So let's keep the y. Let's move the 2x. When the 2x moves to the other side, that's fine. We can move it over there. It loses its sign, right? It was a positive 2x. It now becomes minus 2x. When the minus 5 moves over, it gives up its minus sign. It now is a plus 5. And we still have this 10 here. Is it a plus 10 or a minus 10? Well, there's no sign in front of it, so it's a plus 10. Great. Anything else we can do? Sure, we could combine those, couldn't we? So we have y equals negative 2x. We're going to add these together, and we get plus 15. And this is an equation of a line, and that's the sort of thing we're going to be looking at in this chapter. So this is the reason we're getting used to doing this. Alright, let's do another one. Remember, we want to get the y by itself, and we want to make sure it's positive. Now look, if I look at this y, I can see it's not actually positive. It's negative. So what might be a really smart move here? Why don't we take the y and move the y to the other side? Why is that smart? Because if we move the y to the other side, it won't be negative anymore, it'll be positive. So you will have y on this side. Now, let's leave the 3x over here. Let's leave the plus 7 over here. This minus 1, do we want it on this side with the y? No, we want the y by itself. So why don't we move the minus 1 over to this side, to the other side of the equal sign? Got to give up its sign, so it's going to be plus 1. Okay, can we simplify? Sure, those go together. 3x plus 8 equals y. And you're done. Now, if you want, you can rewrite this as y equals 3x plus 8. Sometimes that confuses people. They say, well, wait a minute. You said that if I move something to the other side, you have to change the sign. Well, that's true when you move one thing to the other side. Like if I move this negative y to this side, it becomes plus y. And if I move this negative 1 to the other side, it becomes plus 1. But if you change everything, right, I change all this to one side and all this to the other side, then you don't have to change any signs. If a equals b, then b equals a. You don't have to worry about changing any signs. Okay, same rule for this one. Get the y by itself, make sure it's positive. So here's my first y. It's already positive. Good. So let's leave it there. Now, it is 2y instead of y, but that's okay. We'll just leave the 2y there. Let's move the 4x over. So 4x is going to move over and become negative 4x. And then we still have this 8. Well, that's plus 8. All right. Do we have that y by itself? No, because we have a 2 in front of it. What's that 2 doing to the y? It's multiplying. This is 2 times y. So what should we do? We should divide by 2. Now, one way you could do this, you could say, and I'm going to divide this side by 2. But don't do that. Here's what you want to do from now on. You want to divide this side by 2, and in fact, you want to divide every term by 2. Okay? When you put one big divide by 2, it's the same as dividing this by 2, this term, and also dividing this term. And this is going to be much simpler if you do it this way. Because now we just have to simplify. Well, the 2's cancel, and we're just left with y. Negative 4 divided by 2, we can do that. Negative 4 divided by 2 is negative 2. Still have the x, of course. And 8 divided by 2, well, that's just 4. And there you go. Okay? So again, next one, let's get the y all by itself. And we want the y to be positive. So what's probably the first thing you want to move here? Move the negative 9y. We want to move that over to make it positive. So leave your 3x, leave your 18, move your negative 9y over, and it becomes positive 9y. Don't put plus 0. If you're adding 0 to something, it doesn't change anything. So just leave that off. Okay, now we want y all by itself. But we have a problem. We have 9 times y. So what do we got to do? We've got to divide everything by 9, all 3 terms. Okay, I'm going to start from the right. 9 divided by 9 is just 1, so we have 1y or just y. Good. 18 divided by 9 is 2. No problem. 3 divided by 9. That does not equal 3. 9 divided by 3 is 3. This is 3 divided by 9. So you could put 3 over 9, but wait a minute. We could put that in lowest terms, right? 3 over 9 is the same as 1 over 3. If you divide them both by 3, you get 1 over 3x. So there's your answer. Or again, if you don't like having this y all by itself on the right, I'm kind of like that. I prefer to have the y like this by itself. Just flip sides. Y equals 1/3 x plus 2. That's fine. But the previous answer is also equally as good. Okay, next direction. Get the y by itself. And make sure it's positive again. Okay, so what do we got to do here? Well, the only thing we have to move is this minus 2. We'll move the minus 2 to the other side, and the minus 2 will become plus 2. So y equals 3x plus 4, and then our minus 2 comes over and becomes plus 2. Great, are we done? No, we want to simplify if possible, and you can simplify here. Look, we have 3 times x plus 4. Do you know what you're going to do here? You're going to do the distributive property, or mountains, I think I've called it before, because they look like beautiful mountains when you draw this. Feed the chickens, I think we've called it before. What's going on here? Well, this 3 is multiplying by the x and also multiplying the 4. So we have y, then we have 3 times x, which is just 3x, and 3 times 4, which is 12. And we also have this plus 2. Oh good, now we can simplify. We just have to combine those. So we get y equals 3x plus 14. Perfect. Okay, this one looks similar. We're going to take the plus 6 and we're going to move it over to the other side. So what we're left with is y equals negative 2x plus 1. The plus 6 moved over and became a minus 6. Now we're going to do the same thing, the distributive property. Multiply, multiply. So y equals negative 2x, because negative 2 times x is negative 2x. Negative 2 times positive 1 is negative 2, and we still have a minus 6. We can combine those. So we get y equals negative 2x. Negative 2 take away another 6 is negative 8, and we've done it. Okay, next big thing, get rid of any fractions. So I have a question for you. If I had a fraction like 2 over 3, what whole number could I multiply that by to get rid of the fraction? It has to be a whole number. Okay, well, 1 doesn't work. 2/3 times 1 just keeps you at 2/3. How about times 2? No, because remember, that's the same as 2 over 1. You'd get 4 over 3, so that doesn't work. How about 3? What if you multiplied by 3? If you multiplied by 3, which is the same as 3 over 1, you'd get 2 times 3 is 6, 3 times 1 is 3. Hey, 6 divided by 3 is 2. Well, that's awesome, that worked. In fact, how come we knew it would work even back here? Because you know what you can do when you multiply? You can ninja slice. These would become 1s, you'd get 2 over 1 or just 2. So if I want to get rid of 2/3, I can multiply by 3. Can you think of another number you could multiply to get rid of the denominator? How about 6? That would work, because then I could ninja slice the 3 and the 6. This would become 1, this become 2. 2 times 2 is 4, a whole number. So 3 works, 6 works, what else works? How about 9? 9 would also work, right? Ninja slice, 1 and 3. 2 times 3 is 6. In fact, any multiple of 3, any multiple of the denominator works. So this takes us to our strategy to how to get rid of fractions. What you're going to do is multiply by the LCD. Remember what LCD is? Lowest common denominator. Write it out if you don't know it, but I think most of you do. So for example, in this question, all I want to do is get rid of the fraction. The only denominator I see here is the 3. So what I'm going to do is I'm going to multiply by 3. But what do I multiply by 3? Every term. In fact, what I should do here, multiply every term by the lowest common denominator. So I have to multiply this term by 3, this term by 3, and this term by 3. Now, you know you've done it wrong if you end up with a fraction in the next step. There should be no more fractions. In other words, I should be able to cancel this 3 out. Can I cancel that 3 out? Absolutely, I can cancel out with that 3. There's a 3 on the top, there's a 3 on the bottom. Remember, when I write 3 there, it's the same as 3 over 1. It's not 3 over 3, it's 3 over 1. So those 3's cancel out. All I'm left with here now is 2x minus 3 times 4y is 12y, and 3 times 5 is 15. I did it. I got rid of the fractions. Now at this point, in the classes ahead, we'll be getting the y by itself or doing different things, but for today, that's good enough. Okay, here's another one. I want to get rid of the denominators. The only denominator I see is 4, so I'm going to multiply everything by 4. This one by 4, this one by 4, this one by 4, and this one by 4. Everything. So I'll know I've done it right if the fractions go away. No more denominators. So this 4 should cancel. Yep, it'll cancel with that 4. They both become 1s. This 4 should cancel. Yep, cancels with this one. They both become 1s. So now we're good to go. We have 1 times 3, which is 3x. 1 times 1, which is 1. X. Oh, whoops, this should be a y here. I'm really sorry. This should be a y. And so should this one. I realized I forgot that. Okay, so this should actually be 1y minus 4 times 2 is 8 equals 4 times 0 is 0. We're done. We got rid of all the fractions by multiplying by the lowest common denominator. Now, these last two are the same idea. The only thing is you have different denominators. You have a 4 here and a 3 here. That's okay. In this first question, what's the lowest common denominator? The lowest common denominator of 4 and 3 is 12. So what we would need to do is multiply all 3 terms by 12. And we'll know we've done it right if we can cancel out these denominators. So let's do it. We can ninja slice here, right? The 4 and the 12 cancel. 4 goes into 12 how many times? 3. It's kind of like you're dividing before you do the multiplying. So 3 goes into 12. We can cancel those. 3 goes into 12 4 times. Those are canceled. Now we're good to go. 3 times 1 is 3, and we still have the x. 4 times 2 is 8, and we still have the y. And then 12 times negative 4 is negative 48. And we're good. Okay, last one. What's the lowest common denominator of 5 and 3? Lowest common denominator is 15. So we're going to multiply this by 15, this by 15, this by 15, and this by 15. You got to get rid of these denominators. 15 and 5. If you go 15 divided by 5, you get 3. If you go 15 divided by 3, you get 5. And there's nothing else to cancel here. So here we go. 3 times 4x is 12x. 5 times negative 1y is negative 5y. And now we have 15 times negative 2, which is negative 30, and 15 times 0 is 0. And we're done. Okay, if you got these skills and you figured them out and everything, I tell you, the rest of this chapter will be way easier than if you have no clue how to do this. So if you are having troubles, let me know, and I can help you out. Otherwise, we'll start talking about different forms of equations next day. See you, everyone. Have a good day.